I'm truly humbled that so many of you have come here today to learn more basically about AWS. And next to you, actually, there's thousands of participants on the live stream from different countries around Southeast Asia watching this event as well. I want to emphasize something that Nick said. This is a day of learning, of education, and there is no better way to learn than to learn from your peers. Yeah, and so we're very happy that actually this keynote is not as much about telling you all about the new stuff that we're doing at AWS. It is sort of more the glue between 4 very exciting customers that are willing to come on stage today and talk to you about how they are using AWS, because that is the most valuable thing you can get out of today. How are real companies being built today on AWS? So, you probably saw the hashtag before, AWS Summit, if you want to post something on your favorite social media channel. If there's something to complain, you can do that to my social media handle. Yeah, don't do that on the main channel. Yeah. And mostly what I want to start off with, I want to give you a little bit of an update on the business, but that's going really quick. And then we'll dive into sort of the innovations that we see happening at our partners, at our customers, and sort of the kind of new things that we're building to make sure that you can continue to innovate at the pace that you want to. Yeah. So we're now 10 years old. That's quite an achievement, I think. Definitely something that has improved is my slide making skills. Yeah? 10 years ago, it was really that we really started to talk about what are the advantages of cloud computing. If I would think that the growth of cloud computing would be purely driven by technology, it is very cool technology, by the way, but that wouldn't make it this big. If we would do just the next step from mainframe to mini to client server to web and now cloud, it would not be this big. The thing that radically changed the whole IT provider landscape is that we put a different economic model against it. A different engagement model, yeah, where in the past you would have to pay upfront for any IT resources that you wanted to get, whether it was servers, whether it was your databases, whether it was your middleware. You had to write this big check, even if you wouldn't use it, or if you really wouldn't use it, all the number of licenses. That didn't matter, you had to pay upfront. Yeah? And you had to make these very long-term commitments, because otherwise you would not be able to drive your price, the cost down. And I've been on the receiving end of that, and I hated that. Yeah? It's also doing things like capacity planning was enormously difficult, because we had this rule of the peaks at Amazon are going up and down. We had a rule that we would buy hardware 15% over expected peak. Now, that is all driven by the fact if you can make your expectations really work. Because if you estimate it too high, yeah, then your CFO would be unhappy. If you estimate it too low, your customers will be unhappy. It's almost an impossible situation. And so we wanted to actually really radically change the way that we engage with our customers. As Nick said earlier, the motto at Amazon is we want to be Earth's most customer-centric company. Now, it's easy to see how that happens in retail. Yeah? But we wanted to apply the same things to us as an IT provider. Yeah? We need to be on our toes every day to deliver to you the absolute best service, otherwise you can walk away. Yeah? There's no contractual obligation for you to stay on Amazon. Now, for me, the definition of cloud is not the technology side. It has to remove CapEx. You no longer have to put capital up front. Yeah? It has to move CapEx to OpEx, but if that be the only thing, that would be just an accounting trick. Yeah? You also have the ability to actually reduce your operational expense. You could do that by, for example, by having more choices of different services, or to be able to release resources if you don't need them. Yeah? There needs to be no more capacity planning. You need to be able to get your access to resources on a second or a minute's notice. Yeah? You no longer should be working on managing all these resources that don't really matter to you. Yeah? And you should be able to go global in a matter of minutes. That's the definition of a cloud. Yeah? And anything that does not meet those 6 characteristics is not a cloud. So let's take a look where we are now. Yeah? We are growing very rapidly, yeah. Financially, definitely we're growing 70% year over year if you start off with 2014. Well over 1 million businesses are running on this platform. Yeah? And if you listen to Gartner, who does this yearly report on the state of the cloud computing industry, it's called the Magic Quadrant, they estimate that AWS has 10 times the capacity of all the other cloud providers combined. Let this sink in. AWS has 10 times the capacity of all the other cloud providers combined. And we're very fortunate that will deliver it. That's for a good business for us as well. Yeah? There's a run rate of well over $10 billion last year. And remember, this is very different from the past. In the past, these large IT companies could get these checks even if you didn't use their technology. $10 billion means that you have spent $10,000 in resources, Alice. You actually have used $10 billion. It's amazing. So this all drives that, AWS clearly has become the technology platform of choice. Yeah, you can see that. Nick had a number of great slides from the region. It's definitely that there is no startup being built today that doesn't start off on the cloud. Yeah, and some of these startups, you may think, oh, they're young businesses. Many of these startups are household names today. Airbnb, Dropbox, Uber, Pinterest. All of these resources, all of these services that you use on a daily basis are all born in the cloud. And if you talk to them, they will tell you that without cloud, they would never have been able to build their business, definitely not be able to scale their business. A great example is Airbnb. Every night, 450,000 people are spending a night in a room brokered by Airbnb. 450,000 people. Every hotel chain would kill for those numbers. They didn't exist 5 years ago. Yeah? And they only have 5 IT people. Yeah? That's the power of the cloud. Enterprises, pretty quickly after we had launched, enterprises had figured out that this was way too good a deal for them as well. And we've been working really hard over the years to make sure that we deliver all sorts of functionality and capabilities such that enterprises can move their workloads, their existing workloads over, but also do dev and test and build new workloads and do lots of innovation on this platform. Public sector, similarly. I mean, for well over 2,000 government agencies are making use of AWS. That means that every dollar that you can save in public sector, you can apply to projects that make a difference to citizens. Thousands of universities and schools are making use of AWS, and well over almost 18,000 non-profit organizations are running their environments on AWS today. We couldn't do this without the help of partners. We are providing the building blocks, the primitives, for you to build on and innovate with. Partners are often crucial in this story to help you be successful on this platform. And there's the existing large integrators, as you know them, but there's also quite a few young, nimble, born in the cloud system integrators that run on a very agile model with you, if that's something that you're interested in. Of course, every ISV in the world makes sure that their software runs on AWS because that's where their customers are. Yeah, and quite a few, there's still software that you need to install, but more and more these ISVs, and take for example Splunk, are going all in onto AWS to make sure that their software runs as software as a service on top of AWS. And all of this we see that this drives tremendous innovation across every possible vertical in the world. Yeah? Bristol Myers Squibb runs their clinical trials on AWS, and they actually can speed up those clinical trials by 98%, meaning that they can bring new drugs and pharmaceuticals to the market much faster. Supercell launches their games on AWS so that on day one they can handle millions of players. MLB, the Major League Baseball in the US, has put missile tracking radars in stadiums so they can track players and the ball, and then immediately the data in real time flows on AWS, and then they can play what-if scenarios on the big screens in this stadium. What if this player, if he had hit the ball and he ran for first base, what if he would have slid? Would he have made it? Yeah? Those kind of things, innovations you see in real time happening. Or FINRA. This is the organization within the SEC that this is the Security Exchange Commission in the US that receives all market data from all the exchanges in the US and looks for anomalies and patterns in the data that they receive in real time. So we see that many of our customers are driving innovation. Yeah, and so let's take a look at what are the pillars of that innovation for them. So for me, innovation always has multiple parts. On one hand, it's technology, and that's sort of a platform that we deliver for you so that you can be innovative. But there's also always an organization and a culture part to it. Yeah? I won't talk about those two pieces, but we're really focusing today on the organization, on the technology part that underpins much of the innovation. One important part there is to remove constraints. That's one of the things that we see. By removing the constraints is what drives sort of the success at our customers. It allows them to be creative, to build new things, because there are no gatekeepers on this platform. There is nobody that's telling you what you cannot do. Yeah, you can do whatever you want with this resource, be as creative as possible. And it makes it easier, because with all these constraints being gone, and constraints are mostly hardware-driven, now suddenly everything is programmable. Everything that used to be hardware and by nature constrained is now software. Whether that's your data center or your servers or your networking or your databases, everything has an API, and with a click of a button, you can launch them or delete them. I think one of those constraints absolutely is location. Be able to launch, maybe you would have friends here and you've been in business longer, and so you know some colo here in Singapore that you could use, but then your business wants to go into Korea. How do you do that? You have to do data center negotiations, network negotiations, you have to get the lawyers in, all these kind of things. On AWS, it's just a click of a button and you can launch your app in Korea. So we have now 12 different regions around the world. We just launched one in South Korea. And this year we'll be adding 5 more. So we'll have a second region in China, a region in India, one in the UK, one on the East Coast in the US, in Ohio, and one in Canada and Montreal. So at the end of this year, we'll have 17 regions. 7 of those are in Asia Pacific. And that clearly signals, I hope, the importance of the Asia Pacific market to us. But all these constraints have always set in your way to move faster, to be more efficient. And I would like to invite on stage Kartik, the CTO of ZALORA, who's going to talk to you about how they moved out of their constrained environment over to AWS. Kartik.
Thank you, Werner. Ladies and gentlemen, good morning to all of you. My name is Kartik. I'm the CTO at ZALORA Group. I'm going to speak about our journey from a physical data center to the cloud. We're actually the antithesis of a startup. We started on physical hardware and then we moved to AWS because we discovered the beauty of it. So ZALORA at a glance. Hopefully all of you have heard of ZALORA, most of you at least. We're the largest fashion e-commerce retailer in Southeast Asia. We've been around for 4 years. We launched at around Christmas of 2011, which is around the time I joined. We launched our websites then, and then we went mobile in 2012. The apps went out in 2013. And in quick numbers, we have about 4 million customers in Southeast Asia across 8 countries. We do about 7 million visits weekly, and these numbers are important because when I talk about switch to AWS, this is what is the main consideration. We have 11 million installed users of our app, and last quarter we shipped about 2 million orders to our customers. So we're a pretty big online retailer. We're only 4 years old, and the story of us going from launch to the cloud is as follows, right? So we started fully hosted in a DC in Hong Kong. So the average capacity utilization of our infrastructure was about 10%. And average is a bit of a shady number, right? Because you have 10%, 99% of the time, and when the peaks hit, you live very dangerously. So we had situations where, we're spending $100 and you only use $10 of it. And then when the peaks hit, and that's when you really need to scale, unfortunately, there were situations when we were running out of capacity. So we had lead time issues, right? So we had to call our data center and say, guys, we need new servers. We have a peak coming up. How long is it going to take? 10 to 21 days. Congratulations, that's the dinosaur era. I mean, we don't scale like that, and it's impossible to run a company of that sort. So we had all of our physical infrastructure covering all the internal platforms, so our auto management, warehouse management, marketplace platform, all of the customer-facing stuff was on it as well. So the apps, the website, all the backend. And it was obvious to us at some point that it's impossible to scale without extremely outsized spend. I mean, it's an insane amount of money just sitting there and gathering dust, and then the peaks hit, and maybe not, you make it. So the nature of our traffic is very bursty. So the hairy spikes that you see there, the baseline to the peak can go 10x, right? So, and it's in the online retail space, as Werner was saying, it's impossible to plan for capacity because your marketing team gives you a demand estimate, and what you see in reality is very different because someone decides to give a massive discount or maybe give stuff away for free, and suddenly you have a ton of people jumping on board. So some of the peaks, this is a real screenshot from one of our countries, our biggest actually. We send out a push notification that says, hey, we're doing a flash sale, or a new brand went live to 11 million users. 2 million of them click on that push notification, and kaboom, everyone hits our platform at that moment, right? And when you're the CTO looking at your New Relic chart, that spike, your heart misses a beat. So AWS. So we figured we need to be on AWS. We did some early experiments with Redshift on EC2 loads. We're sending our newsletters and CRM campaigns using Redshift, munching through clickstream data. And we sort of took this munch as you go approach. So we sort of eat what we can and gradually build capability inside the organization to start using AWS, given that we were not born on the cloud. And so we started moving our staging and development environments to AWS. And over time, we started gaining confidence on the platform. So we said, why don't we do this? Why don't we start moving our live infrastructure over? Because one of the big challenges for me 2 years ago was, can a company of our size with traffic of our volumes be confident that AWS can scale for us? Of course, Netflix and everybody is on AWS, so you might ask, what sort of concern is that? In reality, that was a fear that I had, to be honest. So we said, let's go gradually. So we moved our back-end infrastructure, our warehouses, marketplace platforms, and all of that to AWS. And then it proved the reliability of the platform. We never had any downtime and all of that. So we figured, okay, why don't we go start taking the plunge? So 12/12, it's Singles Day in China, 12/12 in Southeast Asia is a big deal. So we said, let's take the plunge. 12/12/2015 is the biggest day of sales in the history of my company. So I said, okay, I'm going to send traffic over to AWS, and I decided on sending 75% of my traffic over. If it failed, I'd have lost my job. Thankfully, it didn't. We didn't have a second of downtime, and it was a roaring success. We broke all our records, 6 times the traffic of our baseline for the past year. So it was a huge success, and we figured, let's close the drama. Let's switch over. It took me 30 days to migrate all 8 properties. This is a big achievement internally, and also the platform enabled us to do that very quickly. 29th February to 31st of March. Completely switched over. Average utilization perked up to 40%. And for me, the favorite part is my capacity can increase 4, 5, 6, infinite number of times in 15 minutes flat. And that's because my platform has some scaling lag, not because of AWS. So 15 minutes from 21 days is a huge achievement. And for me, it was only possible because of AWS. The side effect was, short story on that. The side effect was that our page speeds increased by 1 to 2 seconds in our 2 biggest markets, also our 2 slowest markets when it comes to broadband speeds. And in the e-commerce space, the holy grail is make it as fast as you can, every day. So we hunt performance with a big axe and try to cut milliseconds off our page loads. So we actually saved 1 to 2 seconds for some of our customers simply because of the proximity in Asia and the Philippines from Singapore. And conversion rate, by conservative estimates, was 10% better in some of these markets. So this is real revenue plus cost savings. And this is what we did to our data center. So we, at the end of March, I told my marketing teams, bring it on, guys. We can take any load you can throw at us. So with that, thanks very much, and over to you, Werner, again.
Amazing. Things that you can now do in 15 minutes, that took 21 days. That changes the way that you, first of all, build your business. It also changes the way that you build software. And so there's something in there as well about the page load times that I want to emphasize. If you build your systems in a sort of decoupled, small building blocks way, you have an ability to actually build what I would call cost-aware architectures. That means that you can build your system in such a way that you have total control over the cost of your infrastructure, how it scales up and how it scales down. And so we have, for example, page load time can become a business decision. How do you improve the latency towards your customers to a point that it doesn't really make any difference anymore on conversion? You can do that by simply adding more resources underneath that. That's something that you can experiment with. You can say, how many more resources do I need to shave off another half a second of a page load time? What's the effect on my business there? So it's clear how much more can I invest in infrastructure such that I can achieve that. And if you're not happy with it, you just dial the knob back. Suddenly you're no longer constrained in doing those kind of experiments and driving your business. So you can be truly creative on this platform because all of these constraints have gone away. Now, it's not just a matter of moving fast and getting access to those resources and in constraint and that they're now programmable. We also, one of the other drivers that helps you be creative on this platform is that we give you a wide variety of these services. It's no longer the case that AWS just delivers sort of the infrastructure services. Compute, storage, databases, network. That's definitely that we did in the beginning. It's somewhere where we were, let's say, in 2008, 2009. Actually, I think that quite a few of the other players in the market are still at that particular level. We're listening very closely to our customers what their other pain points were. What are the things that they really wanted to do that they actually thought that didn't really matter to their business on the infrastructure side. There's a great classical paper by Nick Carr. It's called IT Doesn't Matter. And Nick was really good in writing catchy headlines. He didn't really mean that IT didn't matter. He meant that we all have to do IT. And as such, IT is not a competitive differentiator. The only thing that is a competitive differentiator is what you do uniquely for your customers. And that's not IT. And so we started looking together with our customers, what were the other pain points that they were having that didn't matter for their business as being a competitive differentiator. So, for example, around analytics. Of course, the outcome of analytics matters to your business, but not how you run them. You want to run MapReduce or Hadoop? Do you really want to run that yourself with reliable master nodes and firing up all these things and making them reliable? There's so much heavy lifting in there that doesn't really matter. What you're interested in is the outcome. And so we started building these platforms and services for you so that you can be successful. And that is in many different areas. Whether it is indeed in analytics, or whether it's in application servers, or whether it's a mobile or in IoT. All of these areas, we've built services for you to be able to allow you, give you choice. We also have another principle. And the principle is called primitives, not frameworks. What I mean by that is the old world of software development. Often the company told you how you shall develop your software. Now, if that's what you like, then that might be a good pattern to follow. But we saw so much new development happening on top of AWS that we weren't that arrogant. That we knew that you wanted to have a toolbox with all sets of different tools. and you pick out of that toolbox exactly the tool that you need. Yeah, and so we wanted to make sure that you could have choice, that you could decide how you want to build your systems. And not even only from this particular set. There's a wide variety, there's a very rich ecosystem that sits around AWS. And AWS is so much more than these 70 services. For example, do you want to do telephony? Do you want to integrate that into your app? You make use of Twilio. Do you want to do mobile payments? You integrate Stripe. Yeah, so all of these different services provided on top of our platform make this platform so rich that you can exactly pick and choose the kind of things that you want to do. Yeah, so, but let's dig a little bit deeper into some of these blocks, because it's not just these 70 services. Yeah, within them, we make sure that it's not just broad, it is also deep. It's not just that there is one virtual machine type, one instance type. No, we know that all of you have radically different workloads. Some of them may be compute intensive, some of them may be I/O driven, others may be memory bound. We want to make sure that you have choice in each and every one of those. And make it easy for you to make mistakes. But it wouldn't be the first time that as an engineer that we're looking at our applications thinking like, that one is I/O bound. And then when you run it for a week or two, you start to realizing that it is compute bound. Now, in the past, when you had to buy hardware, you were toast because you had made the decision to buy that specific piece of hardware for what you thought your constraints were. In this new world, it's no longer the case. In this new world, you can make mistakes. If you decided that you wanted to have an I/O optimized model and it turns out you need CPU, one click of a button and you have a different instance type. It drives you to allows you to make mistakes, which I think is sort of the base of creativity and experimentation. You can do whatever you want because you can roll it back at any time. And actually, on the previous slide, even to the point, I think we just released a new instance type called the X1. Because quite a few of you want to run truly memory-intensive applications. For example, you might want to run SAP HANA or Apache Spark, or both of them run very well in very high memory environments. So we built this new instance type called the X1 that has 2 terabytes of memory. It also has the new Haswell processors in there, because you don't want to have just memory, you want to go very fast in parallelism as well. You can have well over 100 cores, virtual CPUs running on that processor. And again, we give you, if you look at databases, we give you choice in your databases. You pick which database you want to run. It might be that you want to have a high-end enterprise-grade database, a SQL Server or Oracle, or maybe you want to use one of the open source ones, like MariaDB or Postgres or MySQL. Again, you have choice. You can choose them. These are managed databases. You don't need to worry about the management of it. You can just run it. Or, take another area. Let's dive into there's access controls. Let's just pick one of those. We give you, again, a wide variety of tools and mechanisms such that you can totally protect yourself. Really put all sorts of policies in place. Who is able to access, perform which operations under which conditions. So all of this brings together a pretty rich platform. And let's go back to one of the more boring ones that you might think about. Object storage. If you look at, we have a wide variety of storage options for you. S3 and Glacier as object storage, EFS as a file system, EBS as a block storage. Much of those running on SSDs today. And but SSDs are becoming sort of the core of most storage operations. And why? Because I think many workloads have changed over time. They become much more random I/O driven, much more transactional, fast-moving kind of operations, huge burst levels sometimes, and SSD are perfect for that. We see that, for example, with quite a few of our customers, a number of our customers are running Mongo or Cassandra. Those are clearly modern databases that are not I/O optimized. They drive a lot of random I/O, and as such, these beasts are really good in that. However, there's still quite a few, there's still this other type out there. This is called these magnetic disks, the disks that we always had. Can we do something with them? Actually, there's some advantages to these magnetic disks. Yeah? Even though these days we say disk is the new tape, yeah? There's still advantages to them. First of all, they're really cheap, yeah? So you can buy a lot of them. And they are actually really good at sequential throughput. Yeah? If you want to stream data out of your storage environment, they're really good at that. And so we decided to launch last week 2 new EBS volumes. One of them is called the ST1, that allows you to stream up to 500 megabytes a second out of your storage environment. And the second one, that is a bit more for cold storage, like where you can get 250 megabytes a second streaming for half the cost of the ST1s. These 2 are going to be, or are already actually, very popular with those of you who have big data workloads. Yeah? It really has the best price performance characteristics for big data workloads. Now, if you want to stream logs out of your storage environment and process them, some real-time streaming or support for data warehousing, these new EBS volumes are going to help you drive your cost of your storage environment down significantly while getting massive throughput out of them. And we already had quite a few customers on this platform. I think Loyalistics, I think they run well over 37,000 applications or something, 2.5 billion installs of them, drive their storage costs down by half. Yeah? Splunk, well known in the log processing environment, has reduced their cost towards you also of storage tremendously by making use of these new magnetic data stream optimized EBS volumes. Now, if you think about removing constraints, it was always the fact that, yes, okay, we can move faster, but you have to worry at that moment, can we still be secure? Yeah, because these were sort of trade-offs that you had to do in the past. It almost seemed that security was an obstacle to be able to move fast. Well, that was definitely a constraint that we also wanted to remove for you. Yeah? At the physical level, we have a very broad set of accreditations and certifications at our platform. Definitely the hardware, the data centers, they are continuously audited by third parties, and those reports are available for you if you wish so. And our physical security is extremely strict. I cannot get into a data center. Yeah? What should I do there anyway? Yeah? It's definitely, these things are so physically secured that we make sure that you get the absolute highest security levels as well. We do forever. Security will be our #1 priority. It will also be our #1 investment area. Whether it's on the operational side, sort of under the covers, where we do all sorts of operational protection for you on the network, on your host instances. We'll continuously invest in that and innovate in that area. But we also give you a whole range of tools so that you can protect yourself in ways that you could never do before. Yeah, so for example, VPC, and you'll see that coming back on many of the architecture slides today. VPC, the virtual private cloud, allows you to coordinate off of our cloud, piece of our cloud, assign your own addressing blocks to it, connect them back to on-premise if that's what you would want to do, and totally manage the networked environment there. Web Application Firewall allows you to work with us to keep bad actors out that are sending you malicious level 7 traffic. Yeah. Many tools around identity, which is crucial, I think. Also, we meant to make sure that those of you who need to run in hybrid situations, these identity management tools actually really federate well onto what you're doing on-premise. Encryption tools are increasingly becoming important. If you've visited one of these summits a number of years ago, you might remember that I was always close off my presentations with telling you, please encrypt your data. Yeah? At minimum, you should encrypt your critical business data and your personal identifiable data of your customers. And it doesn't really matter whether you run in cloud or whether you do this on premise. You should do this in both cases. Yeah? It is just good security hygiene to encrypt critical data to your business. It also means that if you encrypt your data, you are the only one who decides who has access to your data, not us as a provider. We don't want to be in that position. Yeah? We want to make sure that you decide who has access to your data, not us as a provider. And so we're giving you all these different tools and integration into our services to make it easy for you to encrypt your data. Take Redshift, a data warehouse service. Each data block is encrypted with a random encryption key, and then that set of random encryption keys is again encrypted with a master key. We can generate a master key for you. Yeah? But we urge you to actually bring your own master key. If you bring your own master key, you are the only one who decides who has access to the data that lives in your data warehouse. Yeah? Extremely important. The new encryption SDK that we just launched also makes it easy to integrate encryption into all of the programs that you're building. Yeah, such that we want to make sure that encryption is as easy to use as you could ever imagine. Now, remember that 5-6 years ago, we were discussing whether HTTPS was too expensive. Now, every consumer service runs over HTTPS. Yeah, that's no longer a discussion. And I'm confident that we'll go the same path with encryption. Pretty soon, encryption will be default for all of us to use, and which is how it should be. Many of you have compliance regulations that you have to work with. And whether that is regulators that put these constraints on you, or maybe it is just policies within your organization. And you want to make sure that you have the tools to make sure that you can be in compliance with whatever you choose to do. We give you a range of tools, and for example, I like in there config, which automatically discovers the resources that you have, and config rules, where you can make decisions about what you want to do with your AWS resources if you launch them. For example, you can put a rule up that says you're only allowed to launch EC2 instances inside a VPC. Or every instance that you launch needs to be at least a member of one security group. Those rules you can put in place there. Yeah, that works really well. We also help you look at your environment. Yeah, we launched something called Inspector that helps you look at your environment and see whether you are in compliance with a sort of the set of best practices or some of the regulations that you need to be. So let's take a quick, deeper look at the Inspector. What it does, it just looks at all of your environment, you know, the network, the VMs, application configurations, things like that. Compares that against a set of best practices as well as a set of regulatory requirements, and then generates reports for you whether or not you're in compliance with this. And you can do this in real time. So in real time, you know whether your application environment is still in compliance with the rules that you've set for it. And then, you know, those reports, of course, you can do in real time. It's also something that you can share with regulators or maybe your security team within your organization. And Inspector is already integrated in many of the different third-party tools there as well. Trend Micro, great sponsor of this event, has their booth outside. Go talk to them if you want to learn about how they are integrating Inspector into their products. So we've moved away from this world where it was either move fast or be secure. Yeah, I think we've shown you that with the tools that AWS gives you, you can move fast and stay secure, which is really important. Automation also plays a very important role in all of this. Yeah? Being able to automate all the processes that you have, but also, you know, for example, automate your development process. Yeah? Continuous integration is a very important tool in a world where you want to move fast and be innovative. And I'm very happy that we have Palani here from Open Data here in Singapore. Yeah, Data.gov is part of the IDA, who's going to talk to you about their development processes and moving fast on top of AWS by developing a very innovative platform for Data.gov. Palani.
So I'm Palani. I'm from Data.gov.sg. Data.gov.sg is Singapore's open data platform, and we are a team of 5 who are part of Singapore's government digital services, and we rebuilt Data.gov from the ground up. Our mission in Data.gov is to help people understand and also use public data. And we are trying to achieve that by using dashboards, tidy data, data narratives, and also developer APIs. So we wanted to do all these things, and like everyone else, this is how we started out. So one EC2 instance running all the services that we need. After the initial prototype stage, we moved on and we started splitting out the instance. So we started using RDS for the database. And from early on, we felt that doing live environment testing was very important. And to do that, we needed to replicate our setup. So this is how we did it. So we used VPCs and private hosted zones in Route 53 to completely replicate our setup. And together with continuous integration service and Docker, we are able to deploy code into these services within a minute or so whenever we have new code. And AWS allows us to do this kind of setups painlessly and also quickly. Last month, we launched our developer portal, and at the core of our developer portal is 3 services: API Gateway, Lambda, and DynamoDB. The sources of our data for our APIs are agencies like LTA and NEA, and to get data from them, we are using Lambda and ECS. And we wanted to provide historical data for all APIs that we have. And to do that, we are using DynamoDB to store the data. One good thing about using AWS is you indirectly follow and also learn about a lot of good software engineering best practices. And AWS puts these positive constraints on their APIs and how their services work together. Take Lambda, for example. The code that you write for Lambda has to be stateless, loosely coupled, and cohesive. And we saw the benefit of this sooner than we thought we would. So when we started developing our APIs, Lambda wasn't available in Singapore, but we still decided to use it. And soon we got feedback from our users that the speed of the APIs was not as fast as they expected. So we needed to make some changes. So this is how our serverless architecture looked like initially. And what we had to do was to move this portion of the public-facing APIs out of Tokyo region and move it to something in Singapore region. And because of the way we had written code for Lambda, we moved to a bunch of EC2 servers and Elastic Load Balancer pretty easily. And with just 100 lines of code, we were able to make our APIs 10 times faster. So the benefit here was the freedom to move things around when things don't work out the way you expect it to. So this is how our current architecture looks like. Other than the services that I've already talked about, we also use S3 and Glacier for backup. We use CloudForge for logging. And we also get notifications on Slack whenever we do deployment so that we can keep an eye on the deployments. And we are always looking to improve things. And at the moment, we are experimenting with network file systems to persist data between Docker containers. And the goal here is to move towards ECS and EFS in the future. So that's how we have been using AWS for Data.gov.sg. If you want to find out more, you can visit Data.gov.sg. And thank you, and have a great conference.
Very cool. I love the idea of platforms being built on top of our platform. Yeah? And especially those organizations like Data.gov here, who are looking to enable innovation. Yeah? They want to drive innovation by making data available in a programmable way. Yeah? And so I'm really looking forward kind of applications will be built on top of open Data.gov here. Yeah. So continuous integration plays an important role in becoming more agile as an organization, where you don't want your development to happen in these big block steps. Yeah? And so one of the tools that quite a few of our customers are using is Elastic Beanstalk. Beanstalk is an environment, a managed application environment for you. Yeah? You take care of a few of the pieces in your application. You develop in Java or .NET or whatever, or Go, or whatever your favorite language is. Maybe you pick some containers type strategies to go with it. And then you pick a platform that you want to run it in, whether you want to just run it on AMIs, or whether you want to use Tomcat or Nginx or any of those environments. And then Beanstalk takes care of the rest. It takes care of managing instances, takes care of the load balancing and scaling, and things like that. Yeah? But in there's still a bit of heavy lifting that we were looking at, whether we can help you with that. And that's sort of the platform updates. Yeah? So if there's a new version of Amazon Linux coming out, or a patch update to Tomcat, you had to restart your overall environment, you had to patch your environment. Patching environments is in my eyes, not a good automated, secure and reliable way of upgrading your systems or patching your systems. You really should be looking at doing this more and more in an immutable way. So where basically you build your next environment and switch over to that next environment in a seamless fashion. Now, can we help you with that? So we're looking around with Beanstalk whether we can automate this for you. And so we launched last week platform updates for Beanstalk that help you to no longer have to patch your systems, but can make use of this sort of immutable delivery environment. So let's take a look how this looks like. Yeah, so this might be your environment. Yeah, you get requests coming in, they run towards a load balancer, and you have this auto-scaling group that holds your applications. Yeah? Now, if you want to update that, what you do, you make this a blue-green style deployment. So you create your green environment with your new version. You launch the first instance. You do all sorts of health checks on it to see whether it's working correctly. And then Beanstalk will automatically populate that group with the right number of instances that was also running in the blue group. Yeah? And then it becomes just a matter of flipping the load balancer. Yeah? So you can flip the load balancer to the other side and drive traffic to your new set of instances. Yeah? You let the blue group run for a while to make sure that the green group is indeed healthy and working correctly. And if not, you can flip back to it. That's the power of it. So once you're happy with it, you can delete the blue group and you get this whole new environment where your platform is updated to the newest version of software without you to having patch running systems. That makes it a lot more reliable. And already you can see sort of a pattern there. Yeah? You want to make sure that you can build your software build and operate your software in the simplest way possible. And why is that? Because there's a great law by a well-known systems researcher out of the 70s, John Gall, that says that a complex system that has been built as a complex system almost never works, always fails. A complex system, because after all our systems are becoming complex over time, but a complex system that has been built out of simple components and evolved into a complex system has a much higher likelihood to be successful over time. So we want to make sure that you have these simple building blocks that you can start off with, that you don't need to engage with complexity from day one. And actually, on day one, we already had something for you that was pretty simple. Yeah, actually, even its name said simple. Because S3 actually stands for the Simple Storage Service. And so, we really wanted to make sure that you could get store objects and retrieve objects in the most simple way. And I think one of the most powerful things we did with S3 is that all objects are HTTPS addressable. Yeah, you can just integrate it into anything that you want just by a simple HTTPS call. It scales. You don't have to worry about the scaling of it. The cost is driving down continuously, definitely with economies of scale. Yeah, remember, after all, at AWS, we lowered our pricing 51 times if you helped us through your economies of scale and if we were able to innovate in sort of getting other efficiencies in as well. It's highly reliable. I mean, it's got 11 nines durability guarantee. And so all of these things, suddenly you no longer have to think about your storage environment. It just works and gives you very low latency at the same time. So this is a real good building block for building internet scale applications that need to get complex over time, but you don't no longer need to worry about this particular piece. So can we do more? Yeah, we were asking ourselves. And so one thing that we did there was, next to storage, actually start thinking about what can we do at the compute side. So what is still the complexity that many of us have to deal at the compute side? Yeah? So I think there's sort of three styles of compute. Yeah? On one hand, there's sort of the long-running installed software kind of environments that you may run on an AMI, yeah? The Amazon Machine Image. That might be the output of a configuration process. But you don't output an AMI every 5 seconds or every 10 seconds or 10 minutes as an output of your development process. It's output of a configuration process. Yeah, and you might update these AMIs through patching, not necessarily through building a new AMI. And then there's a container approach. Yeah? So AMIs in my eyes live days to weeks or months. That's how long they run. Yeah? And then you get containers. Containers is sort of the Docker style of this world. Actually, it's really the output of your development process. Yeah? You develop and you output a new immutable Docker container that you will launch instead of the other one that you were running already. In my eyes, Docker containers run sort of a manner of, I would say, sort of hours. Yeah, that's sort of the lifetime. It scales up and scales down and allows you to build these sort of microservices architectures. But still, in each of those cases, you have to manage that stuff. Yeah, you have to manage your AMIs and your instances. You have to manage your containers. We were thinking, can't we make this much more simpler than that? Just like that we've done with S3, can we make something that really is sort of simple, scalable under all circumstances, low cost? So we developed AWS Lambda. Yeah, so with Lambda, you can deploy your code in seconds. Yeah? And you get billing on a sub-second intervals. Yeah? And you don't need to worry about servers ever. Yeah? Remember this, there's no server that is easier to manage than no server. Yeah, and so Lambda has become such a powerful tool. You just write some code. Yeah, and it can be in JavaScript, it can be in Java, it can be in Python. You just drop your code somewhere, say what kind of events it needs to respond to, and that might be events coming from an API gateway, as we've seen in the Data.gov example, or it might be system events, like new files arriving in S3, or new items arriving in your Kinesis stream. So this has driven a rise of a complete new architectural pattern that makes sure that you can develop your applications without ever having to launch a server. Yeah, so many of these companies are already doing this. Yeah? And for example, Adwell is a great example. I think they received 300 terabytes of data a month and they stored it in S3. And they had to actually run a whole fleet of EC2 instances just to monitor that S3 buckets. And then whenever a file arrived, they would retrieve the file, operate on it, and then send it out to their ad servers that are around the world. Now with Lambda, they can have completely deleted that whole EC2 fleet. And now in response to every new file arriving, yeah, a Lambda function gets triggered that does that operation and then pushes things out to their ad servers. Totally revolutionized their architecture, becoming much simpler. And I like to believe that if your architectures become simpler, you have a much higher likelihood that they are secure, reliable, yeah, scalable, with decent performance, good performance, predictable performance, and at the lowest cost possible. So take, for example, Bustle. These guys have built a complete web environment without running one server. So they make use of the web server functionality of S3. They put their HTML files there. There's some JavaScript that talks back to the API gateway that triggers Lambda functions for all the typical actions that you would do, whether it's some search or create an update, which then talk to DynamoDB, which is also a managed environment. So no servers to run here at all. Or FireEye, this is actually an interesting one. They're making use of Lambda, and all of these arrows are basically Lambda functions, to implement MapReduce in Lambda. Basically, take data, spread it out over multiple Lambda functions, units running in parallel, and then take the result back and reduce that to a step that is being then pushed back into S3 without running one server. And we're very fortunate that later on you'll see a great demo of this device. This is the Amazon Echo. It's just a device that you may have heard of. It's a voice-activated device. But where this device actually connects to is the Alexa voice service. Yeah? And this is a platform that lives in the cloud. Actually, this device doesn't do that much. The device has some good microphones in it, does beamforming, does speech synthesis, has some speakers in it. That's all it does. All the functionality of this device lives in the cloud. Yeah? And how do you program that device? Because it's a platform. Anybody can write code for this platform. Yeah? And so you do that by writing Lambda functions. Yeah? You no longer have to run servers or anything to add functionality to this. And so there's also the companies have added actually extra functionality to this device. For example, Uber. You can now say, hey, Alexa, send an Uber to my home. Or actually, this morning I read a very funny article of a developer that had integrated this Alexa service with his Tesla car. And so he can now say, hey, Alexa, drive the car into the garage. And so that one then connects with his car. Apparently that's something you can do. And it drives the car into the garage. There's some security issues there, I think, that he will need to deal with. But, you know, I can already see my kids going, car in the garage, car out the garage, car in the garage. Yeah? But it's cool, it becomes a platform. And you don't have to run servers for it. You just write some code. You drop it into the platform, and Lambda executes that for you. Now, yeah, so it becomes also the tissue, what's called connected tissue between all the other environments. So CloudWatch events is something we've done. You get all sorts of events coming out of CloudWatch. You can react to that in Lambda functions. Lifecycle hoods, ELB, the elastic load balancer. You can get notifications. You can actually get functions executed whenever they scale up or scale down. Many of these other areas. And also, you know, so can we do more on the data store side as well? So, you know, DynamoDB clearly is the other missing piece in all of this, or missing piece in this, that has the same functionality. When we started to develop DynamoDB, we really wanted to think, how can we make this as simple as possible for you? And we looked at all the old databases, and all this configuration and management systems around it actually only had one goal: to get consistent performance out of the database. Yeah, and so what we did, well, why can't we build an environment that where you can just tell us what performance you want out of the database, and we'll do that for you. And so that became the interface to DynamoDB. You tell us what level of reads and writes you want, and we'll execute on that, making sure that you get consistent performance out of your database. And as you can see, there's many companies making use of DynamoDB as core piece in their innovation strategy. You know, Mapbox, well over 200 million users accessing all the data continuously that lives in their mapping environment. And there's many more of those. Not just, we don't have just these through, you know, storage, compute, and databases. There's many other services that are all managed, and where if you make use of them, you never have to run a server ever again. So second strategy is, of course, all around data. Yeah? Data becomes more and more important in all of our lives. It sits inside of our, all the data that we collect. We get all the data analytics. It drives all businesses. And we give you all these core components for these big data workloads. You know, whether it's on the storage side and whether it's on the analytics side, all of these tools are available for you. Now, But moving data into the cloud is sort of still a challenge. You have to figure out exactly how to do that. Yeah? Persistent connections is one of them. There's a great way if you have in an on-premise environment, you can build direct connections back into our data centers. But there's sort of different types of patterns that we see in uploading data. Yeah? One of them is around small and frequent. This is sort of the real-time pushing of very small, high-volume data items. For that, we built Kinesis streams for you. Yeah? So where you can ingest billions of data items that get pushed into 3 availability zones to store reliably for you, and then in real time we trigger processing for you, either for Lambda or for EC2 instances, that's what you want. Now, quite a few of our customers said, yeah, but you're doing that, but we're doing it in a very simple way. Can you even make it simpler for us? So we created Kinesis Firehose, where you just take data in, and you just want to store it in one of our data storage options. That might be in S3 or in Redshift. And so Firehose, you can connect them with different backends, and just data that flows in automatically gets stored in there. And now also, one of the new targets for Firehose is our Elasticsearch engine. There was a third pattern that we saw there with this data, that you want to run analytics while the data is coming in. And so we give you an environment called Kinesis Analytics that allows you to write very simple SQL statements that will operate on the data as it is coming in real time. There can be things like moving average and things like that. Very simple ways. Now, Kinesis is becoming a tool for taking in, for example, also lots of data out of the IoT, the Internet of Things, the domain. And I'm very happy that Garagot of TTET is actually willing to come and talk to us here on stage from Thailand, from Bangkok, about the amazing tools that they've been building for this system called T-Square.
Thank you very much, Dr. Werner. Hello, everybody. We are really appreciate to have a chance to share our story from Bangkok, Thailand, and attending this AWS Summit this year. Firstly, please let me introduce myself. My name is Karakot Wongpai Sansin. I'm from Toyota Tsusho Electronics, Thailand. And as Dr. Werner said, that our company name is too long, so we call ourselves TTET. So TTET has been established in 2005. We provide 3 functional business units. The first one, it is device trading business unit. The second one, it is the embedded software development. And the newest one, it is the connected contents business unit. So from the day one that we have the company, we combine all the business together. And today, we would like to introduce you one of the work that we launched in the connected contents business unit, so-called T-Square. T-Square is a traffic information broadcasting service that was launched in 2012. Since from 2011, we installed the GPS hardware module for 10,000 taxis in Bangkok and area around. From the day one, we were monitoring the GPS signal, which was uploaded to our cloud server in every 3 and 5 seconds in real time. The data itself was pipelined to the data analysis engine for the contents creation. We applied the big data analytic technique to analyze and create, for example, the contents that I show you on the screen, the traffic flow status, to visualize the traffic density, to analyze the traffic anomaly, incident detection, and last but not least, in 2011, when Thailand had the flood disaster, we used the GPS signal to analyze the area that were flooding. So let's go in the deeper architecture. From the day one that we applied the AWS technology by utilizing the EC2, ELB, DB instance, and S3 storage, we could perform and provide a high quality of the service, up to 99.5% of the SLA to our automotive customer. And it is very convenient for us to scale in and out the system, scale up and down, And even in the term of the security point of view, in the last year that we faced the brute force, we faced the heartbeat concern. With the official support from the AWS, we can handle this simple, and very immediately. And because AWS has already provided us the powerful tools to manage the cloud resource, from the day one, we could bring the concept of the DevOps team to our engineering team. So we can form the small team to handle this. And another benefit that I want to introduce to you guys is in the term of cost and value competency increment. Last year, we start to optimize our system once again, and we can reduce the maximum of the cost up to 35% because of the AWS tool, so that we can simply to reconfigure our system to meet the cost target. And in the term of the value increment, how about that? So we plan to extend our service into the IoT business area. And the upcoming sensor that will come to the system, we have to pump up our system. So last year, we pumped up the performance of the transaction rate up to 2,500 times by using the Kinesis technology. So because we want to bring these three values to our customer: convenience, performance, and sustainability. To achieve these three core values, with the AWS as our supplier, technology supplier, and they always keep supply and provide a new function. We are looking forward to integrate Lambda, AWS Lambda, AWS IoT, AWS ML, machine learning, Cognito, to achieve and bring our value to our customer and to distinguish our quality of the service for the next business. Thank you very much. ขอบคุณครับ
Such a smart idea to put this functionality in taxis in Bangkok. If you've ever driven in Bangkok, you know it's very important to know where you can and where you cannot go in real time. Yeah. So remember we were talking about moving data into the cloud. Now, this is really where you have a huge amount of small items. Kinesis works really well there. But sometimes you have huge data sets. And unfortunately, we're still constrained by the speed of light. So some of our customers may have data sets that are so big that it would take days, months, weeks, whatever, to actually get it over to AWS. So isn't there a better way to do that? And for that, we introduced something called AWS Snowball. It's a physical device that you can request through a click of a button in the console. And we'll ship this device to you. It has a very small e-ink display in the front. It will give you instructions how to load data onto that device and then ship it back to us. So we have a new version of that has that can hold 80 terabytes. Sorry. You can put them in an array, then you get many more close to petabytes. But no, it can hold 80 terabytes. It is a rugged device. So you can drop it from quite high and falls down. The data, it does not get destroyed there. And we have security integrated into this. Again, remember that I mentioned earlier, encryption is really important. So in this case, what you do, you encrypt the data before we help you with encrypting the data before you move it onto the device. If the device ever gets lost, nobody gets access to this data. So what happens then is you ship the device back to AWS. You store those keys in the Amazon Key Management Service. So, and then we can make use of that to decrypt the data and move it into the storage engine where you want it to have. And you can have a whole range of these in parallel, if you want. You know, with 10 of them on your network, it clearly saturates your 100 gig network with data to load them. You can load them very fast, ship them over to AWS. Yeah? Do not underestimate the bandwidth of a FedEx truck. Yeah? So lots of customers are making use of this already. They all have large data sets, moving them over. Philips, for example, is building their healthcare platform on top of AWS. They already are sitting on huge data sets and are making use of Snowball to move that data and migrate that data into AWS. And by now, and we haven't launched this long ago, we have already shipped so many Snowballs that they could go around the world 30 times. With well over 500 billion objects stored there. So that's huge and infrequent data movement. And then there's this thing in the middle, which is sort of medium-sized files, but things that you do upload relatively frequently. And again, also those are sort of hampered by the speed of light. Long distances, especially if you're a bit further away from some of our regions, it makes it actually, you have to work hard to get this data into these files. Now, we had already done the inverse of what we want to do, not ingestion, but distribution. The CloudFront network, which has 53 POPs around the world, allows you to accelerate data distribution towards your customers. So can we make use of the same environment to also ingest your data? Yes, we can. So we've built Amazon S3, the transfer acceleration, that will make use of our CloudFront POP network around the world to ingest data and move that into Amazon S3. And it goes a lot faster than doing this yourself directly. We see typical speed ups of 3 to 4x over what you would be able to achieve if you would move your data directly into S3. And again, we wanted to make sure that it's really simple for you to use. So with one click of a button, you can just say, I want to make use of S3 accelerated transfers here, and you get a new endpoint, and any data that you upload to that endpoint automatically gets accelerated. It's amazing. Very, very fast, very simple to use. Quite a few customers already have been doing this. These guys, Huddle, for example, they do video analytics on sports video files, moving data over. Jaunt is a very interesting one because there's this virtual reality environment that is very, very interesting. Huge files, uploading those into S3 easily accelerates 3 to 4 times. So we hope that we give you some of these different choices now with whatever different type of upload you need to do. We have the tools for you to be able to do that. And customers are everywhere today. There's not just your web-based environment. Mobile becomes more and more important. We have lots of customers building amazing, amazing mobile applications on top of AWS. But if you look at those applications, there's sort of a duality in it. There's a part that runs on AWS, there's one part that runs on the device, and then you have all these other pieces that run actually in the cloud. Most of these mobile devices are just a window into services and data that lives in the cloud. And so the mobile backend becomes really important there. So whether it's the traditional services that you can access there, or mobile analytics that we have for you, really being able to track your customers there, or giving notifications back to your customers through SNS. And you might have all sorts of other functionality in there, often run by Lambda. And in there sits something called Amazon Cognito. And so that's really a hidden gem in all of this. Cognito actually manages your customers. So they give you an environment on the device where you can keep information about your customer, store it securely, store some state security, encrypt it, and it's continuously synced back into the backend. And you can make choices, for example, when you start Cognito, what kind of user identity you want to use there. It can be, for example, you can use Twitter or Facebook or Google as your social login mechanisms. But I know that many of you do not want social identity. You might want to actually just keep track of username, password for your customers, or email address. And so that's actually still, quite a few customers have been building this for themselves, and it's a significant hurdle. It's clearly undifferentiated heavy lifting. And so we looked at what we can do there for you. So we built something called your identity pool, which is a complete managed environment where you can keep track of customers with their username, password, and all associated information that you want. That makes it user management really, really easy. Yeah? It has out-of-the-box multi-factor authentication, if that's what you want to use. And you can even have email and phone number sort of verification of customers signing up. We do all of that for you. Yeah? No longer you have to worry about implementing these things yourself. And it's not just that you want to connect to sort of these mobile devices, you want to connect to everything. Everything is becoming connected to today. And actually, I'm really honestly convinced that everything that draws a current today, like the Bosch drill that Nick talked about earlier, everything that draws a current will eventually be connected. Yeah, but there's many things that you have to think about in this world of connected devices. You know, why would you connect it to the cloud? Yes, you want to. These devices are actually pretty constrained in their environments. You know, there's not that much computational power on there. There's much more of that available in the cloud. You might want to run analytics on the data that actually these devices generate. And you want to make sure that they're really secure. Yeah, and so you get these interactions. Yeah, you can want to run code in the cloud as much as possible, because updating sort of firmware on these devices is not a simple task. Yeah, you want to run also code in the cloud that controls these devices. On one hand, you have sensors that generate data, but you have actuators that act on this data. Doing all of this has a lot of heavy lifting. And we know this because we had quite a few customers that had already been building this kind of environments on top of AWS. Yeah? For example, Tata Motors in India. They're instrumenting 200,000 trucks that are running on the road in India to really keep track of them and prevent breakdown by doing preventive maintenance on them. And so we've got many of these customers that had already been building these environments on top of AWS. So we looked at them and built AWS IoT as a platform for them, so that makes it easier to deal with all these things like what kind of protocols to use, how to encrypt, how to identify with it. And let's take a look at what are sort of the different components in the AWS IoT platform. Yeah? It starts off with having an IoT gateway. Yeah, that's basically where your devices connect to and where you can identify them with. Yeah? Of course, you have software that runs on the devices itself. We give you a device SDK, or many of our partners that build this hardware deliver this device SDK with it. And it's very important that each of these devices are uniquely identified by an X509 certificate, which you can also use to encrypt the data between the device and the gateway. You can use our X509 generated certificate, or you can bring your own if that's what you want to do. Then you've got the rules engine. All the data that flows into the gateway goes through the rules engine, and you can then, in very simple statements there, actually do some pre-processing. For example, if temperature goes over 20 degrees, start the air conditioning. Some simple things like that. Or you can connect it, of course, to other services that are running within AWS. And there's still this problem that many of these devices that we're talking about may not be connected all the time, especially not if you want to control them. So let's take care of that piece as well. And so we developed the concept called device shadows, where you, as you're developing it, can write to the device shadow, even if the device is offline. Whenever the device comes online again, it picks up the instructions from the device shadow to actually operate there for you. Yeah? And with that also comes a device registry. You can say, for example, something like, give me all the lamps in this room, assuming you will have access to them. Yeah? And things like that. So the registry keeps track of all the devices that you own. All of that comes together in this IoT platform that allows a lot of innovation in the IoT world, because you no longer have to worry about all this heavy lifting that's set in there. So to close off with this last section, I think, which is part of innovation. Now, experimentation is crucial to innovation. And remember, the core notion of an experiment is that you don't know what the outcome is. Yeah? Because if you really know what the outcome is, it's not an experiment. Yeah? And so as businesses, we want to continuously experiment, measure, and learn. And learn is really important. Yeah? Because even if things don't go well, you might learn from them. And what we see is, especially these days, when many organizations are looking at digital transformation, yeah, where digital transformation is a necessity for them. Why? Because competition for companies, established businesses, may be coming out of every direction. No longer is access to resources, for example, a stumbling block for you to compete with any other business in the pharmaceutical or oil and gas or financial services. All these industries are expecting disruption coming out of area, not of their traditional competitors, but out of maybe younger businesses. Yeah? And so they're all looking, every organization today, whether you're medium-sized or a large enterprise, you're all looking at how can we innovate to deliver interesting, crucial new functionality to our customers to really make sure that our customers remain happy with the products that we deliver. Lots of innovation happening, of course. There are many of our enterprise customers, but it's a journey. It's not something that happens overnight. Yeah, you see, some organizations may start with analytics, some may start with mobile, some of them will do some app migration, and all the way over to that there are quite a few enterprises that have made the decision to go all into the cloud. Yeah, of course, it started all off with Netflix being a really sort of taking the bold step to make a decision to build it on a platform such that they didn't have to think about how to sort of scale all of this and just could focus on building the absolute best video delivery service ever. Yeah, and so whether it's FINRA or whether it is, Intuit with their Quicken products and whether it's universities, quite a few of these have decided to go all in. Kempinski is an interesting one, a high-end hotel chain, if you know them, very luxury hotels. They've made the decision to go all in because in the whole hospitality world, especially in the luxury hotel brands, competition is all about digital services. And so they want to make sure that their engineers, the best engineers, don't have to keep the lights on of the servers, but can focus on building stuff for their customers. There's a step, of course. Nobody goes all in, especially not if you have an existing environment. It's clearly a journey, yeah? And many of these customers are underway in this journey. Yeah, for example, Johnson & Johnson has a range of applications already running on AWS, and they're adding more and more over time. We really want to help you there. Yeah, I think we have absolutely the broadest set of services available for you, such that you can manage both on-premise as well as in the cloud. And whether it is compute with being able to move between AMIs and VMware instances, integration in vCenter, for example, so that you can use vCenter on-premise to also manage your AWS environments. Many of these things, integration with federation between IAM, making sure that, for example, OpsWorks, our management environment, can also manage things on-premise, all of these kind of things. Yeah, that means that you go on a journey. Yeah, Capital One has made a decision to indeed move all of their significant workloads over to AWS. That doesn't happen over time. Started off with some experiments. They're moving some dev and test over and realizing how solid and fast moving this environment is. And then you start thinking about maybe building some new products on top of AWS. And then you start maybe migrating some of these other services over. General Electric, one of the biggest innovators in this world, started off with actually moving some apps in their oil and gas division. That had such a great success that GE is now moving 9,000 workloads over to AWS and is closing 30 of their 34 data centers. So if you look at all of this migration, there's a few pieces to it. The first, training and certification. People need to know what they're doing, of course. Data migration, we've already talked about that quite a bit. And database migration. Oh, wait, that's not the same as data migration. Yeah? So let's see if we can help you there as well. Yeah, so we built the database migration service that helps you migrate from on-premise into the cloud, into the same type of database. Yeah, we can do this in real time without you having to take your applications down. Yeah, and since we launched it early last year, we migrated well over 1,000 production databases of our customers using the database migration service. But sometimes you want to migrate between different types of databases. Mostly, customers are running enterprise-grade databases on-premise, but don't want the same thing in the cloud. They really want to go to something that has, let's say, enterprise-grade database style in the cloud, but open-source performance. Yeah, you want to have the best of both worlds. Well, we actually help you with that as well. You can migrate between engine A and engine B, different types of engine, by making use of the schema conversion service. Yeah? It converts tables and views and things like that. It also takes care of procedures and triggers to be able to help you as input into the migration service. And indeed, Amazon Aurora is that target often. Amazon Aurora is the fastest growing AWS service at this moment. It's a database that we've built that has a MySQL front end, but in the back end has the performance and the reliability of an enterprise-grade database. It took us 4 years to build this, and we built something really magnificent there. Data that flows into Aurora gets replicated over 3 availability zones, twice in each availability zone. So you get 6 copies of your data, making sure that you get consistent performance and high reliability out of this database. Yeah? Even in my eyes, sometimes with much better performance than the traditional commercial enterprise-grade databases, but at a fraction of the cost. For example, take Expedia. Expedia is, I think they're moving 300 million rows into their database on a daily basis. Typical transaction patterns are 17,000 rows per second, with a typical latency of 17 milliseconds per each of those operations. All on Aurora, all at the cost of an open source database. So all of these, we talk databases. You still need to move your applications, of course. Can we help you there as well? Well, that's a bit more trickier because you may have developed your applications, you may have partners had developed your applications, you may have sometimes off-the-shelf software in combination with things that you developed yourself. There may be also the dependencies because you've been running this application for the past 10 years, maybe also the dependencies that you don't know about. So we developed a tool there for you called the Application Discovery Service. You can run this on-premise, and it will sort of try to discover how the application is built, what kind of components there are, what the dependencies are on other systems, and all of that information gathers it, how the network layouts are. It collects all that information and creates reports there for you automatically, and stores it then, encrypted of course, in S3. And then often what we see as a pattern is then you will use that report with some of our partners. Maybe some who are then working with you, going through the report, trying to pick applications that make most sense in terms of migrating them over to AWS. The application discovery service is available for everyone at this moment. So I hope that we've given you a bit of a view today about how we help you innovate. We continue to innovate under the covers for you, building new features and services, but also just rock solid in terms of performance, hardware, data center innovation, so we can drive your costs down, help you drive your costs down. And we hope that with all of this, you will be also starting to think about how to reinvent your IT and your information technology, and the role of information technology and, for example, analytics in your environment. And we hope that you take an experimental approach with that. Really experiment, measure, and learn is a really cool process to actually build things for your customers, see how they're responding to it, and then either amplify or maybe turn around and take a different approach. So with that, I think there has never been a better time to build very cool systems for your customers. So with that, go build.